Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about chemical bonding chapter. Now we are going to see in this session about covalent bond formation. In the earlier sessions we have seen what is chemical bond, how it is formed, and types of chemical bonds. And out of those we have seen already about ionic bond and its characteristics. Now we are going to see about covalent bond and its formation. The bond formed by the equal contribution and equal sharing of electrons between two atoms is known as covalent bond. Here, co represents sharing and valence represents valence electrons. So the chemical bond formed by the equal contribution and sharing of valence electrons is called covalent bond. Jean Lewis explained about covalent bond formation. Let us recall once about the ionic bond. What did we say about ion bond? The chemical bond formed by the transfer of electrons, one or more electrons between the atoms, is called electrovalent bond or ionic bond. There will be complete transfer of electrons, one or more electrons from one atom to another atom, and hence there one positive ion and negative ion will be formed. So in that way, between those two oppositely charged ions, attraction occurs that we call as ionic bond. But here differently, elements they don't lose electrons and they won't gain electrons, just they will share the electrons mutually. Then the bond formed is called covalent bond. The chemical bond formed by the sharing of valence electrons between the atoms is called covalent bond. This was explained by Jean Lewis. Since the formation of a covalent bond results in the formation of a molecule, it is also called molecular bond. Yes, here by the covalent bond formation between the atoms there occurs a bond between fixed atoms, and hence we can say this is also a molecular bond. Covalent bond is also called molecular bond. Whereas in the ionic bond case, there is no linkage between the atoms. There is no formation of molecules. There occurs just the attractions between the oppositely charged ions from all the surroundings, from all the directions. Okay. So there, that is why the ionic compounds occur as crystals, solid crystals. Whereas covalent bond occurring in between particularly two atoms, and hence it results in the formation of molecules. So that is why it is called molecular bond. On sharing electrons, both the combining atoms get an inert gas configuration which gives stability to the compound formed. So by sharing of electrons like this between the atoms, both the atoms will get the nearest inert gas configuration, and hence the atoms will get stability and thus the compound is formed. Okay. When is a bond formed between the two atoms is being covalent? We told when atoms they transfer electrons, ionic bond is formed. And when the covalent bond is formed, which kind of atoms they form covalent bond? When non-metallic atoms come together, the tendency to donate or accept the electrons is not possible due to less electronegativity difference. Yes, when two non-metallic atoms they come together, we know non-metallic elements generally they will be having greater electronegativity. All the atoms will be ready to accept electrons. But when you bring two non-metallic atoms together, what happens? Both will be ready to accept electrons only. No one is ready to donate electrons because both will be having greater electronegativity, and the difference between the electronegativity of these atoms will be somewhat less. Hence, there is no tendency of either donating or accepting electrons. Both will be ready to gain the electrons only. Thus, in order to acquire stable configuration, that is, without losing and gaining electrons, without losing and gaining electrons to acquire the stable electronic configuration of nearest noble gas. Sharing of electrons takes place between the two atoms, resulting in the formation of a covalent bond. Okay, in that way, two non-metallic atoms, when they approach each other, non-metallic atoms, they won't be ready to lose electrons generally because of high electronegativity. And when both are non-metals, hence no transfer of electrons occur. So when these two approach, they share their valence electrons mutually, and hence both atoms will try to acquire nearest noble gas configuration, and thus a covalent bond is formed between them by sharing electrons. Generally, if the electronegativity difference between the two nonmetals is less than 1.7, then a covalent bond is formed between them due to their combination. Yes, if the electronegativity difference, if it is greater than 1.7, if the difference is greater, then one atom will lose electrons, the other atom will gain those electrons, and hence ionic bond will be formed. If the electronegativity difference between those two atoms, if it is less than 1.7, if it is less than 1.7, means the electronegativity difference is less, both are having greater electronegativity, then no atom will lose or gain electrons. Both will mutually share electrons, and hence they result in the formation of a covalent bond. Okay. For example, as the electronegativity difference between two hydrogen atoms in hydrogen molecule is 0. If you say two hydrogen atoms, we know both are hydrogen atoms, both will be having same electronegativity, isn't it? Because both are same kind of atoms. Then what will be the difference between the electronegativities of these two atoms? 0, isn't it? Because both have same. There is no difference at all. Therefore, the transfer of electron is not possible. If both are having a difference of 1.7 or greater, then there is a possibility to transfer electrons. One atom which is having lower electronegativity will lose electron, and the one which is having greater electronegativity will accept that electron. But if the electronegativity difference is less, and in the case of hydrogen it is completely 0, isn't it? Both are having same electronegativity. So the difference between the electronegativities of these two atoms is 0. Then there is no question of either losing or gaining electrons. Then what happens? Hence, the two hydrogen atoms combine due to the electrostatic force of attraction developed by the sharing of electrons. See here, both the atoms sharing these electrons. This hydrogen contributing one electron, this hydrogen is contributing one more electron. Each one electron they are contributing. And finally, they become two electrons. If you observe this hydrogen atom, it acquired now two electrons, so that it is getting the nearest noble gas helium configuration, and it became stable. If you observe, in the case of this hydrogen, it also acquired two electrons by sharing. So this also acquiring the nearest noble gas helium configuration. In this way, both the hydrogen atoms are becoming stable by attaining the nearest noble gas helium configuration. This is done by sharing of electrons or mutual sharing of electrons, and hence a bond formed between these two atoms. That bond is called covalent bond. Okay. Representation of covalent bond. The covalent bond between a pair of atoms is represented by a small line. Generally, in writing the representation of the chemical bonds, just between the symbols of those two atoms, a small line like hyphen is mentioned that represents the covalent bond between those atoms. For example, if you see hydrogen molecule, H2 molecule can be represented as HH. So here this line represents covalent bond between these two hydrogen atoms. Okay. Now let us see here what is meant by covalency. Valency means we know the combining capacity of an element. Covalency means the number of electrons shared by an element in the molecule formation or in the formation of covalent bond is called covalency. Let us see the definition. The number of electron pairs shared between two atoms of the same element or different elements during the formation of a molecule is known as covalency. The number of electron pairs shared between two atoms. Okay, electron pair in the sense set of two electrons. If you see hydrogen molecule here, we know each hydrogen is contributing one electron for sharing, isn't it? So that these two hydrogen atoms are sharing these two electrons and hence they are forming a covalent bond. Now how many pairs of electrons are shared between these two hydrogen atoms? Single pair, that means two electrons. So the number of electron pairs shared between these two atoms is called its valency. Now the valency of hydrogen in H2 molecule is 1 because here two hydrogen atoms they have shared mutually one pair of electrons. That number of pairs of electrons shared between the hydrogen atoms is called its covalency. Okay, let us see some more examples here. Covalency of hydrogen in hydrogen molecule, just now we have seen it is equal to 1, and that of oxygen in oxygen molecule is 2 because in oxygen molecule two oxygen atoms mutually they share two pairs of electrons that we are going to see in the further classes. Okay, how it is formed. Anyhow, in oxygen molecule each oxygen atom will share two pairs of electrons or each contributes two electrons and hence finally both will share two pairs of electrons. That is why we say the covalency of oxygen in oxygen molecule is 2. Okay, conditions favorable for formation of covalent bond. Let us see here what are the conditions under which conditions a covalent bond is formed easily. Let us see here. Covalent bonding is all about sharing of electrons. The ideal conditions necessary for atoms to share electrons are, one among them is atom should be of small size. Yes, it is one of the conditions because atoms should share the electrons. So if they have smaller size, they can strongly share the pair of electrons between them. If they have bigger size, they may get the tendency of losing electrons. So ionic character increases for them if the size is more. So if both the atoms are having smaller size, then easily they can form covalent bond. Okay. Next property to be there is they should have high electronegativity and ionization potential. Yes, if both the atoms participating in the covalent bond formation, if they have high electronegativity and ionization potential, then they form easily covalent bond and strong covalent bond will be found between them. Okay. And even the electronegativity and the ionization potential of the combining atom should be almost the same. If they have almost the same ionization potential and electronegativity, both are comparatively, they both have same electronegativity. Then what happens? Both the atoms will contribute the electrons equally. Then they form covalent bond very easily. If one is having greater electronegativity, what happens? That will try to take the electrons instead of sharing. That will try to take the electron from other atoms. If both are having almost same electronegativity, what happens? Then they will share the electrons, and hence they result in the formation of covalent bond. So these are the favorable conditions for the formation of a covalent bond. Favorable conditions for the covalent bond formation are satisfied by the 5th A, 6th A and 7th A group elements. Yes, what we said, the elements should have the smaller size, the atom should have smaller size to form the covalent bond. Yes, it is there for these elements because we know in a period in the modern periodic table from left to right size gradually decreases. So the right side elements in the periodic table are having smaller size. These are the right side elements, 5th, 6th and 7th group elements. Isn't it? Nicogens, chalcogens and halogens. These easily form covalent bonds. And even they have greater electronegativities and ionization energies when compared to the remaining elements in the periods because they have very smaller size. and hence these elements have greater tendency to form covalent bonds. The electrons in the outermost shell of in these elements of 50A, 60A and 70A groups are 5, 6 and 7 electrons respectively, isn't it? Nitrogen family, that is 50A group elements, nitrogen family also it is called. They contain 5 valence electrons, because if you see nitrogen example, its atomic number is 7 and if its configuration is written 2, 5. So there are 5 valence electrons for these elements. So these elements are having 5 valence electrons and the sixth group elements are having 6 valence electrons and the seventh group elements are having 7 valence electrons. For example, if you see fluorine 2, 7, there are 7 valence electrons. So in this way they have 5, 6, 7 and valence electrons respectively, and they can have stable octet configuration by sharing 3, 2 and 1 electrons respectively. If you observe for fifth group elements, how many valence electrons are there? 5 are there. Still, how many electrons are needed for this to become stable? 3 more electrons. That's why these 50A group elements will be ready to share 3 electrons with other element. Okay, if we see for sixth group elements, the number of valence electrons is 6. Then how many electrons are needed still to become stable? 2 more electrons. If it gets 2 more electrons, it will get the octet configuration and hence it becomes stable. That is why these 60A group elements will be very ready to share 2 electrons with other elements. Similarly, if you observe seventh group elements are having 7 valence electrons. How many electrons are needed for them to become stable? Still 1 more electron. So these 7th group elements, when they combine with other atoms, they will contribute 1 electron for covalent bond formation. Okay, in that way, the molecules formed among the elements of 50A, 60A and 70A group elements are mostly covalent molecules. Okay, let us see some examples of these 5th, 6th and 7th group element molecules. If it is sulfur dioxide, these are of 6th group elements. PCl3, phosphorus is a 50A group element, chlorine is 7th group element. For phosphorus bromide, sulfur fluoride, we can sulfur hexafluoride, sulfur chloride, iodine fluoride, oxygen, nitrogen, fluorine. If you observe, these all are non-metals of 5th, 6th and 7th A group elements. So this mostly they form covalent bonds. When they combine themselves, they form covalent bonds, because these all elements are having smaller size, greater electronegativity, greater ionization energy. So they will tend to share the electrons always when they come with the similar kind of atoms. Now let us see some examples for the molecules having covalent bond. See first example, formation of chlorine molecule. Chlorine atom has 7 electrons in the valence shell, isn't it? We know chlorine atomic number is 17 and its configuration will be 2, 8, 7. There are 7 valence electrons, isn't it? So in the formation of chlorine molecule, each chlorine atom contributes 1 electron and then the pair of electrons is shared between the 2 atoms. So both the atoms acquire octet configuration of nearby noble gas argon. If we say this is one chlorine atom, how many valence electrons are there? 7 valence electrons are there, because here in the configuration the last shell there are 7 electrons. These are called valence electrons. So if there are valence electrons number is 8, that atom will be stable. But for here chlorine there are only 7 electrons. It requires one more electron. If you observe, for this chlorine, valence electrons are represented with the crosses. For this they are represented with dots. But both represents valence electrons only, no difference. Just to give the clarity, as these electrons are of this chlorine and these electrons of this chlorine, to show the difference. So for one atom they are shown with the dots and for other atom they are shown with the crosses. So when these two chlorine atoms approach each other, this chlorine atom will contribute one electron and this chlorine will contribute one more electron, and hence they share this pair of electrons. Now if you observe for this chlorine atom, how many electrons are there in the valence shell? Already there are 7 electrons. It is shared one more new electron. Now it became 8. By this getting 8 electrons, this chlorine acquired the nearest noble gas argon configuration. In the similar way, this chlorine also, if you observe, already there are 7 valence electrons and it acquired one more electron by sharing. Now it also getting 8 valence electrons. Thus, a covalent bond is formed between these two atoms by sharing of a pair of electrons. Can we say now the valency or covalency of chlorine here? How many pairs of electrons are shared? 1. So the covalency of chlorine in this molecule also will be 1. Same chlorine molecule can be represented even like this also. Cl and hyphen Cl. This hyphen represents the covalent bond between two chlorine atoms. Okay, let us see next one more example. Formation of HCl molecule. Both hydrogen and chlorine contribute one electron each, and then the pair of electrons is equally shared between hydrogen and chlorine. So hydrogen acquires the configuration of helium and chlorine acquires the configuration of argon. If you see here, hydrogen has only one valence electron. It requires one more electron to become stable like the nearest noble gas helium. What about chlorine? It has 7 electrons, so it also will acquire the stable configuration by gaining one more electron. So when these two atoms approach each other, they'll share a pair of electrons between them, and hence hydrogen will get helium configuration, chlorine gets argon configuration. Thus both the atoms become stable and a covalent bond is formed between them. Okay, same HCl molecule can be represented like this also, HCl. Let us see one more example. Formation of water molecule. We know oxygen atom has 6 valence electrons because atomic number of oxygen is 8 and its configuration is 2, 6. So as it has 6 valence electrons, it can achieve the configuration of neon by sharing two electrons with other atoms, and one with each hydrogen atom. Okay, it is ready to share 2 electrons and hence it will get extra 2 electrons in sharing, so that it becomes stable like nearby noble gas neon. So oxygen will share 1 electron each with 1 hydrogen. So in this way, oxygen has 6 valence electrons, each hydrogen has single electron. So when they approach each other, 1 electron of oxygen is shared with 1 hydrogen, 1 more electron is shared with 1 more hydrogen. Thus, oxygen is getting octet configuration of neon, each hydrogen is getting helium configuration. Observe it? In that way, two covalent bonds are formed, one with each hydrogen. This also can be represented like this. It is called H2O or formation of water. Okay, let us see one more example. Formation of methane molecule. You know, methane molecule means its molecular formula is CH4. Okay, it is called methane. Anyhow, here the central atom is carbon. Carbon has 4 valence electrons, isn't it? Because its atomic number is 6 and its configuration will be 2, 6. Sorry, 2, 4. There are 4 valence electrons in the valence shell. It can achieve stable configuration of neon by sharing 4 electrons with 4 hydrogen atoms, one with each hydrogen. So each hydrogen atom acquires helium configuration. At the same time, carbon will get nearest noble gas neon configuration. See the picture here, you can understand. See, carbon has 4 valence electrons and it is shared each valence 1 electron with 1 hydrogen atom. By that, carbon achieved octet configuration of the nearest noble gas neon. At the same time, each hydrogen achieved the helium configuration so that all the atoms became stable. Thus, 4 covalent bonds are formed between carbon and 4 hydrogen atoms. Okay, this also can be represented like this structurally. So, this is about a covalent bond formation. So a covalent bond is the bond formed by the mutual sharing of electrons between the atoms. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.